Good day, fellow. Today we are still going to continue with electron configuration. But now we are going to focus on ions. Do you still remember last time I gave you something like this? 2311. It was a neutral. This one was neutral. Then now I'm going to give you this one, a cation. Now you see, a charged. Then how are we then going to write the spectroscopic notation as well as the noble gas notation for the given? Not this one, but now this one. How are we going to do that? Firstly, we consider this formula electrons. We must find the number of electrons, the atomic number minus our charge. We are looking at this one. Now. See, we are looking at this one, not this one. We have +1. Then let's check. We have an atomic number of 11 minus a charge of +1. When we take our calculator and calculate, we get 10. See, this is the number of electrons. We have found our number of electrons. Then now, as a learner, you must not forget that we have first energy level, second energy level, lastly third energy level. S take up to 2, P up to 6, then D can take up to 10. See? Then don't forget to include these arrows for you to do the right thing. See? Then at this point we can then say now spectroscopic notation is going to be as follows. We need only 10 electrons. We are going to take one S first and put 2. Then we are done with this arrow. The reason for this 2, because S can take maximum of 2. Then we move to the next arrow, which is 2S. Can also take up to 2. Then we move to this one now, 2P. Check. 2P can take up to 6. And when we add all of this, we get 10. Then we have answered our electron configuration question, but using the spectroscopic notation. You can also use the noble gas notation if you want to, or if it is not stated to say use either spectroscopic notation or the noble gas. You can use any. Then let us use a noble gas notation. See, how are we going to answer this question? You go to your periodic table. When we go to our periodic table, we can see that we have He, which is 2 electron, and Ne, which is our neon in this case. It has 10 electrons. Some learners would say, okay, since He He, helium, has 2 number of electrons. They will replace this one and put He where they see this one, and then continue to write 2s2 together with 2p6. You see, this is a noble gas notation. But bear in mind that last time we said you must consider the maximum. You see, the maximum. If we look at this, the maximum that this can have, it's 10 number of electrons. And we also have a noble gas that has 10 electrons, which is neon in this case. You see, at the end of the day, neon is going to be the maximum one with the number of electrons that correspond to the given one. Then neon has 10 number of electrons. You see, then we can then replace the entire from here till here with what now? With neon. But don't forget to include what? The brackets when writing what? The noble gas notation. See, so simple. Now let us move to another one. Let's say now let me erase quickly. Let's say if they give us by chance now Fe. Let's say if they give us Fe, F fluoride with an atomic number of 9, then it has the atomic mass of 19, then we include a -1. Then how are we going to write the electron configuration of this one? They also gave us this one, a charged one. You see, we call this one cation, this one cation, this one is anion. You see, then how are we going to answer this one? Using spectroscopic notation as well as noble gas notation. The principle is the same. We start by finding out the number of electrons, which is atomic number, minus a charge. We have atomic number of 9 minus, now we have a negative charge, which is minus -1. See, when you use your calculator, you are going to get plus 10. You see, then it's going to be simple. You see, don't forget to include this negative. You see, it is negative over there. You must also include your negative there. Do you understand? Then at this point we can now say, okay, we have 10 number of electrons. Let us go to spectroscopic notation. Okay, we start with 1. S can take up to 2, then 2s can take up to 2, then 2p. I started with this one, 1s, 2s, 2p can take up to Okay, then now it's going to be simple, because for the previous one we also got 10. Then for the noble gas notation, we take the maximum. Don't forget that the maximum for this one is 10, which is neon. Last time I explained that some will consider HE to say, okay, the noble gas of the first energy level is going to be helium, then and continue to write like this. But at the end of the day, the whole thing gave us 10, which correspond to what? To neon. You see, we are lucky that the fluorine, or yes, the fluoride, it correspond to neon. But now let's say if we had something different, like chlorine. Let's take chlorine and see. I won't erase this one, I'll just remove a bunch there. Let's say if we had chlorine, we know that chlorine with -1, it has an atomic number 17 and atomic mass of 35.5. Then firstly we consider what? Our atomic number, which is 17. See, we write 17 minus our charge. Don't forget to include -1. Then at the end of the day we are going to get 18 number of electrons. Then at this point we can then do our spectroscopic notation. See, let's go. Then the first one takes 2. See, the first energy level takes up to 2 electrons. The second one, 2s. Second R is 2s, can take also up to 2. At this point we have 4. We continue by going to the third one, which is 2p, can take up to 6. Yeah, I can take up to 6. We have 10. Okay, 2p, 3s. 3s. Oh, sorry, 3 is 3. 3s can take up to 2. At this point we have 10 plus 2 is 12. 18 minus 12, we only left out with 6. Then let us go to this one, the fourth one, which is 3p. 3p. You see, 3p can take up to 6. Can take up to 6. When we add 10 to then 6, we get 18. This is a spectroscopic notation of what? Of a chlorine ion. Then now let us do a noble gas notation. Noble gas notation. See, a noble gas notation. For the noble gas notation, we are then going to consider our periodic table. We got 18. From our periodic table we have He, we have neon, we have argon. You see, neon is 10, argon is 18. Neon is 10. Some would say, okay, from here till here we have neon, which is 10, then the remaining, which is 2s2, then 3p6. But now let us consider the maximum. You see, the maximum that we can have for this one is 18, which corresponds to this one. You see, and argon. But when writing, kindly include the square bracket, then write AR, sorry. You see, AR. Because at the end of the day, from here till here, we get 18. It corresponds to the noble gas of what? Of an argon. Then you write argon like this. You see, then this is going to be our final answer. I thank you.